Hello and welcome to Chipsoul Technology. In this demo, I will show you the practical implementation of the Wiegand sensor with the STM32 microcontroller. As well as I will compare the Hall effect sensor and the Wiegand sensor. So you will see. As in the previous presentation, I have covered all about the introduction of the Wiegand sensor, the position of the magnet, and the different uses of the Wiegand sensor. So if you didn't watch the video, so the link is in the description, you can watch it. So let's start with the coding. So first of all, you will have to initialize and declare some variables that I have declared it here, and these are for the Hall effect sensor and the Wiegand sensor, you can see here. Then after that I have configured an external enter for the Hall effect sensor that will monitor the pulses that will come from the Hall effect sensor. You can see here, and this is for the Wiegand sensor. Once the Wiegand sensor output will come, so it will go to the internal comparator in the STM32 microcontroller, and at the output the interrupt will be generated, and this variable will be increment. So due to these variables we will monitor the frequency of the Wiegand sensor as well as the Hall effect sensor. For frequency, I have used the timer interrupts that after each and every second the Hall effect frequency will be counting, and after that this variable will be take at 0. So these are the this is the code that I will also place it in the video description as well, if you need it, so you can download it and you can implement very easily. Okay, so it was all about the code of the Wiegand sensor and the Hall effect sensor, and now we will go to the practical implementation of the Wiegand sensor, as well as I will also compare the Wiegand sensor with the Hall effect sensor. And after that you will easily observe that the pulse generated from the Wiegand sensor and the pulse generated from the Hall effect sensor are exactly the same. Okay, so let's start that. All right, so you can see these are the two sensors. The right one is the Hall effect sensor and the left one is the Wiegand sensor. You can see here adjacent to each sensor there is a magnet which is called the dynamically magnetized magnet, and I had already explained all about the Wiegand sensor and the magnets and the video part number 1. If you didn't watch that video, so the link is available in the description, you can watch it. Okay, so before starting the motor, so this is also the motor, which is the very powerful motor of about 1 lakh RPM frequency. So once I rotate the motor, so the pulse will be generated by the Hall effect sensor as well as the Wiegand sensor. So you will see the result will be exactly the same here in the oscilloscope as well as the live expression. So you will see. Okay, so before starting the motor, first of all I want to explain a little bit the microcontroller board as well. So this is the circuit. The output of the Wiegand sensor is connected to the STM32 internal comparator. You can see here, this is the internal comparator, which is the PA3. You can see in the circuit board. Okay, and the another pin in the Wiegand sensor is connected to the ground. You can see, and at the output of the Wiegand sensor there is a 0.47 microfarad capacitor to remove the noise. Okay, so I had already explained all these things in the video part number 1. And the Hall effect sensor is directly connected to the oscilloscope, and here in the STM32 microcontroller interrupt as well. Okay, so let's start the motor. Here you can see in the live expression as well, the Hall effect sensor value is 0 and the Wiegand comparator output is also 0 in the live expression, and here in the oscilloscope as well you can see. So let's start the motor, and this motor will be controlled by the SCR motor controller. You can see this is the SCR motor controller, so by rotating this knob you will see the motor speed will be changing. So let's change the speed of the motor. Start the motor. You can see, first of all I will start with the lowest frequency, which is the round about 1 hertz frequency. You can see, and the live expression the frequency is almost 1 hertz, as well as in the oscilloscope you can see. Okay, once I change the speed of the motor, now at this moment the motor frequency is exactly the 4 hertz. You can see in the live expression, or 5 hertz. You can see in the oscilloscope as well. Okay, so let me increase the speed of the motor gradually, but I will not talk at that moment because the motor speed will be very high, and after that I can't speak. Okay, so you can see. So it was all about the practical implementation of the Wiegand sensor with the STM32 internal comparator, as well as I have compared the Hall effect sensor with the STM32 internal comparator and the Wiegand sensor. So you easily observe that there is now missing pulse, as well as the comparison between the Hall effect sensor and the Wiegand sensor is exactly the same. So it was all about it.